Hello, and welcome to a special edition of Old Broken Junk. Today, on the bench, I have the power supply from a 1934 Zenith radio. This was fitted into a Ford motor car and is fairly modular. This is just the power supply. The rest of the radio is off camera right now because it doesn't all fit on the bench. But I'm going to be taking a look at this to see what the problems are with it, because it doesn't work and it pops fuses. This is a fairly standard power supply in its design. It has a vibrator, tube rectifier, quite a large transformer, and then a lot of smoothing, choke, and other wound components and capacitors on the board. The idea is that you put 6 volts DC into this and it outputs about 300 volts DC. The way that it does this is the vibrator is electromechanical and switches a set of contacts on and off, very much like the points in a car ignition. It also works in the same fashion that switching on and off and that change from 0 to 6 volts repeatedly is what allows the transformer to take that small voltage on the input and then output much larger voltage on the outside. Once there is effectively an AC output, the rectifier then brings that back down to DC output, and there are some connectors on the bottom where this connects out. There is a high positive voltage, a negative voltage, and then the input. The first culprit is this. This is the vibrator, which is just an electromagnet and a set of contacts inside, essentially. And this should, when powered up, open and close the contacts, and it makes a kind of buzzing noise. You'll hear it in a lot of old radios. This one, when I tested it, does not, and that is very, very common. The contacts inside, although this is sealed up, you may be able to see that it has some solder holding it closed. The contacts corrode. This is coming on 90 years old. Being as this is suspect, particularly as when I powered it up, it did not begin to operate and the circuit drew more current than I was happy. I need to check and see that the rest of the circuit on the board is in good condition, particularly the wound components, so there being the transformer, a couple of chokes. Just because there was a lot of current passing through it at the time, I'm concerned that the windings may have become damaged, very hot, burnt out. So we can check that. The paper capacitors are not staying. They are as old as the device itself, and I don't want to trust them anymore. The wound components are okay. The rectifier tube, we shall see if that works. The other parts of this have a large dual filter can. There is a ballast underneath here for the vibrator, which is not going to be very critical because I intend on replacing this with a modern solid state device. So let's dig in and see if we have any problems that would stop us from going further. Now that that's free, we can see this is 2 capacitors, despite there being 2 connections on the top. Those are individual connections, and the case itself, where it is clamped in, is the common connection for the 2. These usually go bad, they are potted in tar, so I shall be undoing this, making a large amount of mess and putting a couple of capacitors hiding inside to replace these 2. Now that this is out, I'm going to go ahead and just recheck everything and see if we get the same result. So, center tap to primary. If it'll make a connection at all. There we go. 0.3 of an ohm, that's okay. The other one, about 0.3 of an ohm. Across the two, we should get an additive about 0.6, if I connect it correctly. Let's check it across the secondaries again. Still no bad connection. No. Okay, well, being as we had no reading at all, I decided to very carefully pick open the paper wrapping on the secondary side. The two wires that lead out are very, very heavy in comparison, even though they really are not. And inside, the wire is incredibly fine. I have here some 36 gauge, which without measuring it looks about the same, and that is probably so fine that you cannot see it on the camera, but it is about as fine as a hair, and that is wound many turns around the inside. These wires are just soldered to that on the inside, and being as we've had some moisture in here, I'm going to check and see if these wires are okay, or if we get a reading at all. So if I touch across here and touch across here, I don't know if you can see that, but 447 ohms. That's good. Maybe we just have a bad wire leading out, and that's very easy. I can repair this wire and just put a new one on. I have a connection there. And I have a connection there, so it's strange. Why are we not seeing a reading here? And now we are. Oh, okay. Yes. I think we have a broken wire. Well, that is good news. Let me cut these wires off, resolder on 2 new ones, and see where we go from there. And then heat it up and apply a little bit of solder. Make an electrical contact to the new wire. And now what we can do is, once that's just sitting there with nothing touching, select this back to resistance and take a reading across the ends of the new wire. I could catch it. There we go. And across there. Same reading as before, about 450 ohms. Very good. I will tape this back down and clean up the inside of the casing, and that should be this transformer good again. All of the corrosion on the inside of the outer case cleaned up nicely with a brass brush, and that looks good. It was only light, thankfully. On the subject of bad capacitors, this is the dual filtering capacitor. It goes across the output of the high voltage. It is supposed to be 22 microfarads and 8 microfarads, and it's rated at 300 volts. let's take a look and see what it measures. These ones are tar potted and usually are not very good. 7 nanofarads, and the other one 3 nanofarads. That is a factor less than it should be, and being as they are very, very low capacitance, a capacitor is 2 metal plates with an insulator between them. They should not touch. They should not have any form of continuity across them. So if I check on the resistance meter, right there, bring that forwards, this one is reading in at, it's still going down, 6.5 megohms. It's not good. Let's see what this side comes back at. 4.5 megohms. So even my small meter here is able to read the resistance across this, and that is a bad thing, because where you have electrical path through this, any electrical power flowing through a resistive medium generates heat, and the hotter this gets, the more likely the dielectric material between the plates of these is to heat up and to fail. So this is no more good and shall be replaced. I'm curious to see what is wrong with the vibrator. It has most likely just had the contacts corrode. It is secured like plumbing with solder, so I shall heat it up without burning my fingers too much. Let's see if we can take the base off. There we go. Oh, and everything fell out. Well, the inside of there is just a large rubber insert, and the sole purpose of that is for insulation, sound insulation, so you don't hear the thing, because these things buzz. I'm going to carefully put that aside, because now, because of fire, it is quite hot. The inside of this is fairly simple. There is an electromagnet at the top, a small piece of steel which is connecting on a number of points, one of which is adjustable here and then several at the bottom which aren't, and it is dragged forwards and backwards as it opens and closes. So as the power is applied, the electromagnet is moved over. That disconnects the connection to the electromagnet, and then it closes and repeats, so on and so forth. So what I'm going to do is clean up the contacts on this and see if I can't make it work. I'm just going to see which terminal on the base the connection to the electromagnet connects to, and it is that pin. So if I have cleaned this up well enough, we connect this across 6 volts, it should begin to buzz. That now operates. And that's the noise these things make, as you can understand. That was a lot of noise. As you can see, that is why there is a large amount of sound insulation. However, that now buzzes and does appear to be making and breaking contact. Most excellent. Right now, as a test, I have connected the DC bench supply up. We do not have the smoothing capacitor connected, and that's okay just for this test. But this will take the DC input, change it from one side of the transformer to the other to give us AC, pseudo AC, and I'm connected to the output of the transformer, which is going to be an AC voltage out. And if I gently bring the volts up just enough to make the vibrator start to work, that's about 2.4 volts, we have now 16 volts from 2.5. So I'm going to switch that back off again. But that is very good. That is now starting to do what it is supposed to. And connected up for a very quick test. Now getting 15 volts DC. So the rectifier is just beginning to warm up and is producing output, and I'm going to turn that off before it does something that it shouldn't. That is good. So, all in all, the power supply here is doing things that it should do. Just needs a little bit of a refresh on the older components, and this part of the radio will be done. We'll see you in the next installation.